Okay, students, so we're going to be here and today, the punchline is we're going to be proving triangles similar. And this is phase one. So we're going to be proving more, just talking about it. We're not really going to be doing two column proofs, but we will be investigating some postulates and theorems. And today will seem similar to a previous lesson we did, pun intended. But anyways, let's do a quick review of similarity first. Question one, a high definition TV, an HD TV, has side ratio 16:9, all right? So the HD TV, the side ratio is 16:9, so I just converted it to a fraction, all right? The non-HD TV, we'll just call this, the non-HD TV, we'll call that TV, has a ratio of 4:3, all right? Are these two ratios equivalent? There's a couple ways to do it. We can use a trusty calculator. I'm asking my calculator what is 16 divided by 9, and it told me about 1.8. Actually, it's 1.7 repeating. I'll write it like that. And then I'm asking my calculator now, what's 4 divided by 3? And it's 1.3. All right, so by just plugging it into a calculator, we can easily say no. Before I write no, though, I want to show you a different way. You can say, well, 16 to 9, does that equal 4/3? All right, what you're also allowed to do, so I've seen some students like to do this in the past, is cross multiply, and you get 48 equals 36. OMG, that's false. 46 does not equal, or excuse me, 48 does not equal 36. That's preposterous, that's silly, all right? That's someone where, that may be like a Dublin student might think that, or someone from Worthington, but us people in Hilliard, we know that's just false, all right? So no, ratios are not equivalent. So the TVs are actually not proportional. And if you've ever wondered why sometimes there's black bars on the side of them, like onto the left and right of a picture on your TV, it's because when that TV show or movie was made, it was made for the ratio 4:3, not 16:9. Just random fact of the day. But nonetheless, let's progress. Question 2, which of the following statements A through D is false if triangle ABCDE is similar? Let's review this really quick. This squiggly line means similar. And remember, similarity statements are powerful just like congruency statements. So the scale factor is 3:2. All right, well, let's match up some corresponding parts. Let's look at AE. AE is the bookends of the similarity statement. So AE corresponds to QP, because those are the first and last letters over there. All right. So matching that up, we can say, well, AE over QP. Well, the length of AE is 15, QP is 10, so I get 3/2. So it's saying which one's false, not that one. Now, it's asking me for the length of CD. So let's go ahead and compute that. And in fact, I already have the scale factor. I know the scale factor is 3/2. CD is what I need. And what corresponds to CD? Well, that's in my similarity statement, that's the third and fourth letter. That's going to correspond to MN. All right. Again, similarity statements ensure it specifically tells me what corresponds to what. Going to cross multiply. I'm going to get 42 equals 2 times CD divided by 2. CD equals 21. So that's also true. All right. NP. Let me look at NP. All right. I need to find NP. Well, NP are the two last letters. DE. That means it's going to correspond to DE. So again, I'm going to I guess I'll just write this down here. 3/2 is still my scale factor, or my ratio. 3/2. Now DE is 9, and NP is what I'm finding for. Notice how what we're solving for, like in part B, CD was in the numerator, now NP is in the denominator. X, whatever we're solving for, the variable can be anywhere. What matters is my corresponding parts match up. Now remember, I had 3/2. So I had big over small. So that's why 9 is in the top, because it's part of the big shape, and NP is the smaller one. So that's why it's on the bottom. But nonetheless, cross multiply, we're going to get 18 times 3 parentheses NP. Divide both sides by 3, and 6 equals NP. So that one's also true. All right, let me do something really fast. Now we gotta investigate. It's saying we need the perimeters. So we just found NP to be 6. Tick mark 10. So the perimeter of this shape is gonna be 10 plus 10 plus 6 plus 14 plus 8, which we're going to get 20, another 20, another 8, so 48. So the perimeter of that is 48. So, all these are true. Nice little review, though, of scale factors, ratios, proportions, cross multiply, and so on and so forth. Question number 3 is a really good question. I like this question a lot. Marcus says that if you add 2 units to the dimensions of a rectangle, you will create a similar rectangle. Kayla says this isn't correct because they wouldn't have the same scale factor. Who is correct if either? All right, so let's think about this. Let me do it like this, actually. All right, this is some rectangle. We have X and Y. Now, if we add 2 units, that means we make it 2 taller and two wider. X plus 2, Y plus 2. All right. So we're adding 2 units to the dimensions of a rectangle. Will we create another similar rectangle? Well, there's ways to think about this. All right. Let's just pick let's just do a specific case. So when you're like in doubt, just pick, like when we have abstract, like what's X? I don't know what X is. What's Y? I don't know what those are. Well, we're gonna pick some numbers to help us think about this. I'm gonna pick X to equal 1 and Y to equal 2. See what happens. So if we have 1 to 2, all right, we'll call this, well, in this rectangle right here, then this is gonna make this side length 3 and 4. All right, so if we have a rectangle 1 to 2 and then increase both by 2 units, we have 3 and 4. Kind of similar to what I was doing before. Well, we have this ratio of 1 to 2 from this triangle on the left, 3 to 4 from this triangle on the right. Do these equal each other? Well, I'm in serious doubt. But let's cross multiply to confirm. I get 4 equals 6. Not the same scale factor. Not similar. So who's correct? Kayla. Kayla outsmarted Marcus. All right. So again, this was kind of a hard problem. We have some generic rectangle with length X, width Y. If we increase both by 2 units, well, now it's X plus 2, Y plus 2. Well, are those the same scale factor? I don't know. I'm confused. So just pick easy numbers, 1 and 2. All right. You could have picked 2 and 3. Just keep it simple on yourself. All right. And then last review one, triangle BAC is similar to triangle DEF if AB is 5. So remember, let's always try to label. ED is 2, FD is 3. What is CB? All right. So let's use our similarity statement to match up corresponding parts. So I have BA corresponds to DF, or excuse me, DE, I can't read. All right, those two things correspond. All right, notice how it's asking CB. That's what I need to find. What corresponds to CB? Well, that's FD. All right, so I've matched up my corresponding parts. Now let's just be careful when I write this ratio. I'm going to do 5 over BC. So I stayed with the big triangle, made a ratio, and then 2 over 3. And again, once I get this far, it's just a matter of cross multiplying, keeping my work organized. I'm going to get 15 times 2 parentheses BC. Divide both sides by 2. BC equals 7.5. All right, and that's that. Review from yesterday. All right, so we're going to start proving triangles are similar. So kind of like what we did with triangle congruency. What's the bare minimum of information I need to prove two triangles are congruent? We're going to do the same thing with similarity. And the first thing we're going to be investigating is the angles. All right, things to know. All right, so don't you forget this, that similar triangles have congruent angles. All right, the measures don't change. We'll even write that. Just think of an itty bitty equilateral triangle, a very small equilateral triangle, and a ginormous equilateral triangle. All their angles are the same. They're similar. Their angles are congruent. And their sides are proportional. So this is where we make the ratios and all that fun stuff. All right, so kind of looking at this triangle right over here, well, like B corresponds to Z, A, X, or A and Y. And don't you forget the third angles theorem, where like even though we don't have anything about C and X, we only need two angles to know that they are congruent, and then the sides would be proportional. All right. So things to know: similar triangles have congruent angles. Show why this is not true for quadrilaterals, and this kind of goes to one of like that Kayla and Marcus thing, problem we just did. If I have a square has four right angles. Then we're going to do a rectangle. Well, fun fact, did you guys know the definition of a rectangle is a quadrilateral with four right angles? So we could even say that the left and right side are the same as the square, but the top and bottom aren't four right angles. So this fact is not true for quadrilaterals, because in this case right here, we got all congruent angles, but sides aren't proportional. And again, we could even pick simple numbers to deal with to illustrate this point. This square might have sides of all length 1, and this rectangle only might have two sides length 1, and then we could say the top and bottom are 2. All right, so the sides aren't proportional. All right, how we would go from this side to this side is 1, but then that side to that side is 1 to 2. So 1 to 1, 1 to 2 doesn't match up, does not work. All right, now